Good evening, everyone. I think it's been a long day about new technology and new terms being discussed. Some kind of a background to even start thinking about it, right? So the topic is about embedding AI in industrial system. So why we are at least not challenging. So it is required for us to think about whether it is possible to do any embedding or at least any incorporate what kind of a temperature you look like in the water when you take bath or use it, and it can do it by itself, or it can become self-aware of its own problems. And industrial system is something which we design or which we have created with some set objective. It could be a single equipment, like it can be a single closed environment, like you can have a nuclear reactor in a cave, or you can have a HVAC system in a international space station. Problems which will give them the limitation for that. It can stop, it can go to some certain degrees of performance, but it cannot go beyond world, even to run or operate or maintain it. Everything is cost driven, right? And to advanced engineering, right? So all these things are basically a requirement when we talk about industrial system. Although all these systems are made for one particular objective, whenever they are down, they are counterproductive. Qualify anything which is a constitute as an industrial system or not. Now let's talk about what could be a AI system, or what could constitute as an AI system, right? To start with, AI system is a set of statistical and mathematical techniques, very basic, right? It could be a set of equations, set of functions, set of neural networks, whatever you say. It is basically grounded in mathematics, right? And it is assisted by some kind of an advanced computing, right? Advanced computing which will give you next degree of autonomy, meaning it will give you a higher order of control. So if your car is having if it can keep on going till the time you can achieve self-driving car. So the AI systems in the background assisted by advanced computing can give you higher degree of autonomy to the last level of autonomy, which is the self-aware, self-driving system, right? This is what is happening in the industry, and you can relate to anything which you talk. So even the basic of our house, like our call bells, right? They are now getting more higher degree of autonomy. Now you don't have to press the button. The moment they detect the face in front of an door, it will alarm the inside that there is somebody waiting outside the door. There is no need for pressing somebody, because it will give you a touchless control. So it's kind of that is the night environment, the day environment. If a system can be attached to the old legacy air conditioner, it can adapt its cooling dynamics for the day condition and the night condition automatically, rather than you shifting the temperature setting. It will give you that kind of an autonomy by itself, right? So it will give the AI, if attached to a industrial system, it will help you achieve higher degree of adaptability, right? Although still constrained by nature and constrained by physics, but whenever you see an Ola driver or a Ulo driver raising too much, creating too much of an acceleration and braking, and again doing very rash driving, the temperature of the engine block keeps on going, right? And you will see that those particular cabs get damaged very fast because of this high stress keep on building up. If there is a system which we can incorporate in the driving scenario, where we can give an alarm or take action before the driver does that kind of a rash driving, it will create a long life for that. Every car system in the world can be replicated, and it creates a lot of economic benefit right away, right? And ultimately it will reduce the barrier of interactability with any system in the background. As I said before, to interact with any industrial system, say for these cameras or this anything in this world, in this hall, you need to have a kind of a background in that particular system. But what if a general AI which will help you? How do we merge these two into to work together, right? And there are pros and cons in two ways, right? One is you start with a new design or new development life cycle, where you have a concept of a new equipment and you have a concept of a new UI AI system, and you start with that, okay? But when we do this, this is the problem which we face, right? We face that a new development cycle will have higher barrier to cross, because there are two things happening together. the design of equipment as well as the design of system, both are parallelly working together. And if you have experienced in the design process, there are a lot of iterations happen, right? You start with a very low accuracy, but you improve to the very high accuracy when you cannot achieve that higher accuracy all the time, right? So you will see initiatives of giving free products in the industry, where the app is given free. All you have to do is point the camera and take a picture, and it will help you detect a smile, or it will help you detect a face. That is sometimes starting from a very lower accuracy, but when the more and more data gets collected, it gets higher accuracy. So AI and design of an equipment are not actually parallel all the time, right? Because for an equipment to cover up a higher amount of data, it needs to run for a longer time, right? Then only it can connect. So that's why the success rate becomes low, right? And sometimes the business also, end user doesn't want to accuracy. You want to maintain that business line and then bring that to upstream, right? So that's the point. So then there is a next stage. What we want to do is now retrofit. You already have an equipment, you already have a data, now it's a good time to adopt AI, right? So since we already have an installed base, imagine a company which is running a pump in all of the Hyderabad region, and your adoption by end user become very easier, because you can slowly introduce the feature and slowly make the user much more happy with your new products which are coming, right? And it gives times to business to adjust to the new change. It doesn't really suddenly changes. We will come to the point where it will tell you what exactly the changes can disrupt, right? So now we come to the point where we are figuring out how do we merge these two. And so let's take about using that model to train that model and make it much more fit to the problem. And we start evaluating, finally do a deep parameter tuning, and then ultimately start prediction or do that. This is a very standard process, and there are many deviations, lot of iterations happen in the process, okay? And then you come up to a point where you're saying that, okay, now I know what my particular equipment, model and data does, and how it will help you predict something, right? So let's look at the problem. Right now I have a use case. I will not go, but the operating life gets shortened due to internal or external disturbances, right? If it is designed for 20 years, because of the disturbances, the time reduces to 10 years. But since it is an inline process, so changing that equipment creates disruption in the production, and it reduces, and it goes for a loss of revenue for that particular time when the equipment is not working. So there is a scope for AI to make this equipment perform at peak level and very, very higher order of performance. We can use AI system, right? So then there is also a scope for both the industrial and AI system to evolve by learning from each other, right? So let's talk about the equipment. The equipment, BAHX, brazed aluminum heat exchanger, those are specific design areas, but basically you can imagine that this is having very low repairability, so it should never fail, right? And so one phenomena which we are going to study is what we call as thermal stress or thermal fatigue, okay? Because of this, there is having problem of structural damage. The particular what we have experienced in our life, what we have actually experienced and used in our lives. Say for example, you have a nail which is stuck in a board which is not supposed to be there. So how do you break that nail? You take a plier and twist it back and forth, back and forth, back and forth. Ultimately, it breaks, right? What happens there is you start inducing stress in the metal. That stress creates a force which keeps on accumulating. Once that force keeps on accumulating, it crosses a barrier so same thing in any kind of metal construction, right? So in this area we are saying that, okay, we have a cold stream, hot stream interacting inside this system, and when it interacts, if there is a high degree of fluctuation, then this particular metal structure will go under stress, right? So it will be having problem of fatigue, and ultimately can enter into a failure. Passing through the channels, and hot and cold are there, and they are separated like layers of sandwich, right? And these joints, which are very small, are soldered. It's kind of a brazed aluminum, meaning because of temperature and stress, they are binded together. So any fluctuation in temperature stress That's narrow AI. So we understand how the particular system works. There is a physical process, there is a exogenous effect, there is a disturbance effect, and then there is a sensor, which is measured response. So this is the point where I collected data, but that data contains everything else in it. It contains disturbance coming from the start. It contains disturbance generated in the physical process. It contains disturbance which are not from the process but from the environment or something else. Everything is recorded in this YK. Deformity. Previously it was flat, but it has now bent because of that stress. So that is rate of change. If you heat that very fast, then it will change its shape. Okay. So that's basically, you can say, degree C per minute kind of thing. Right? Similarly, I need to understand what is the limit for it. What should not exceed. So you can say YC should not exceed that much limit. Like it could not melt. It cannot go to a red state or high degree of temperature. Okay. And what could be the frequency and fluctuations. So it can go to some other area and it can say that it's a mild stress. Right. It can go to major where it is completely fluctuating. Meaning you are heating the temperature and then suddenly cooling. So if you want to do this, you can heat a spoon on a high degree of temperature and suddenly cool it, it will bend. And it has that high degree of stress built up. So we need to code some wide like fluctuations happening. These are the temperature fluctuations. Some regions are not having high fluctuation, some are some are having fluctuation. So wherever we are seeing the fluctuation, we are giving them a tick mark. Like this particular lines are the tick mark. One fluctuation. We have to qualify this. Okay. We have to understand how this gradient is cumulative and how this is affecting the equipment. So we want to get to the next level of approach. First was narrow approach where I quantify everything. Now I asked the AI to approach. This is broad level approach, right? Here I am asking AI to tell me what are the high density areas, what are the high density. So these are the few parameters we have to figure out, right? So high density meaning you have lot of stress in a very short amount of time, right? This is somewhere 5 degrees, 3 degrees and something like that. The bidirectional is also there where your temperature is going up and down again, right? So we are quantifying and getting them approach, right? So based on this, we found out some parameters and figured out that we can predict the damage in the equipment, right? So this was not also enough. This is also broad, not complete AI. So what is, or is it coming from a external source, right? So it should be able to learn and adapt and adjust accordingly, right? From previous reactive state, it should go to the self-aware state, meaning it should self-aware, become aware and tell that the damage is already going to happen. And it should tell the operator to change the control accordingly. Right? And ultimately, when the system of any AI, industrial system becomes AI enabled, there is a question needs to be asked. How much of a control you want to give it to AI? How much of a control you want to keep it to human? If you want to start with a right away full control autonomy, I'm sure none of us will be happy to sit in a self-autonomic car unless and until we are comfortable with it. Right? We never know ultimately do we want to give 100 principles we used to incorporate AI. Right? We know that embedding of AI system requires few resources than original desktop. Right? Your car doesn't need a full Intel i7 processor. Right? It is having still 8-bit processor which is very low. And where exactly you want to process the data? Do you want to process the data where it gets generated, or you want to bring that data to the central server and process it? So these are some decisions you need to make. Okay, what kind of real-time operating system you want to use? So RTOS are different from the Windows operating system or any other Apple or anything. These are very, very rudimentary basic principles operating system which are designed in a very low code language, and it can run on a very high reliability. Right? What kind of component you want to add to the original system? How it will recover from an error? Okay. And what kind of AI ready hardware you want to do? So one of the biggest example is like there are TVs which are now AI ready, meaning there are no solutions for AI, but in future if there is a solution coming from an producer, they might send it to over the air OTA and then give it the feature to the end user. So that could be AI come up with the solution. So in original sensor equipment, there is low amount of instrumentation. So we want to add new sensors to the external body, so that it can understand what are the temperatures which is happening inside the equipment. But that is not enough. We need to do something else. We need to add a little bit of a metal which will replicate the same, have some kind of a new alarm or reporting structure for somebody to take action, and some kind of future connectivity for control to take action. If there is a high temperature variations happening, then some control will take action and normalize that temperature variation. Okay. So with this design approach, we can. Okay. Delete this.
Sir, can you give us a practical system where this AI system is installed?
Yes, it's a practical life system in our industry.